Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the finally block. I'm going to open up my web browser, my website, javacjava.com, select menu, Java OOP tutorials. I'm going to scroll all the way down here to exceptions finally block. So this tutorial will build on concepts from my exception handling try and catch tutorial. At the core of exception handling there is one more code block that needs to be addressed. The finally block. The finally block is a code block that always runs regardless of any exceptions in the try block. The purpose of the finally block is to execute statements that must run because some sort of mandatory condition. The most common use of the finally block is to close file handles that may have been opened in the try statement. Now the structure looks like this, right? And if you watch my try catch, it basically goes from here to here, right? You got your try block from here to here, your catch block from here to here, and then your finally block from here to here. Statements that always run. These statements don't necessarily have to be related in any way to the try block. Oftentimes they do, or the catch block, or so on and so forth there. But there are certain rules that apply to the relationship between try, catch, and finally. So no independent statements can exist between the code blocks of a try, catch, finally statement. At a minimum, a try block must have either a catch block or a finally block. So catch block is optional too, as you can see, right? So a finally block will execute even if there is a return statement in the try or catch block. A finally block will execute if there are exceptions or no exceptions. Basically, all the time. The only way a finally block will ever fail to execute is if program termination occurs, which is extremely rare and usually abnormal. So, now this tutorial also includes concepts from the following tutorials. Oh, I got a little typo there. Exception handling, try and catch tutorial, try catch index out of bounds exception tutorial, try catch arithmetic exception tutorial, and try catch number format exception tutorial. So I'm going to go ahead and scroll down here to the source code, and let's go ahead and highlight all this. I'll be going over a lot of stuff in today's tutorial. Let's hit Control-C to copy, or right-click and select copy. I'm going to move the browser off screen here, and I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really fast by right-clicking, selecting New, Shortcut, CMD, Next, and Finish. It's just that easy. I'll type in Java C and then hit Enter. You should see all this stuff scroll by. However, if you get an error message, watch my tutorial on installing the Java Development Kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space /. CD is short for change directory, / tells it to go to the root. Now I'm going to make a directory here called Java with the MD command, and I already have that folder, but if you don't, it'll create it for you. Change directories to the Java folder, and I'm going to make a directory here called try, catch, finally, okay? And notepad try, catch, finally.java. Okay. Let's go ahead and paste this in here. Okay, don't worry about this up here yet. And I got this commented out here, but basically I've got this class try, catch, finally with the main method entry point. And we're not going to worry about this file intro until the very end because it's just a little bit more advanced than where this tutorial series is at the moment, but I think it's good enough for you guys to kind of take a nice leap ahead and understand it, I'm sure. So the first thing I've got is int x equals 0 up here, and on the first try statement here I'm going to set x equal to the result of this expression, 13 divided by 0, which if you've been watching my tutorials you know that's going to throw an arithmetic exception. And I'm going to catch the arithmetic exception e, and I'm going to display to the console this string literal plus e contains the, it's an arithmetic exception object, and it inherits the get message from throwable, right? So that'll display that there, right? And then I'll display finally, first finally just executed, throw up a new line. All right, let's go ahead and just run that here. I'm going to get a little bit more, but we'll just ignore it for the time being. invoke the try catch finally class here. So caught our exception, right? And first finally just executed. So finally executes irregardless of this. So I'm gonna go back to the website here. Actually, not quite yet. Maybe in just a second here. All right, let's take a look at this next one, this next try finally here. You notice there's no catch here. And one of the things I said is, you know, it either has to have a try catch or a try finally. I've gone through plenty of tutorials there where I've just done try catch, so I'm not going to demonstrate that. But here's a demonstration of finally here. So I've got this string S array initialized to these 3 values here. Each element, first element hello, second element world, and third element no problem here. I'm displaying to the console the length -1, the one that's at that particular index, not necessarily element. Remember, indexes start off at the number 0. And that'll show you this right here, okay? So we get no problem here, second finally just executed. All right, so let's check something else out down here. Ignore this one right here. So the next one here, I'm displaying to the console, calling the return statement. Then I go ahead and call return, right? And then I'm going to display to the console inside of the finally block, right? Because remember, finally always executes. So finally even runs after a return statement, okay? So here's what the result of that was. Calling the return statement right there, right? And then we call return. And you can see finally even runs after a return statement. So that's pretty cool. All right, now one of the things I said is that you know, the only time you can get finally to actually not run is basically if you were to have the program terminate, you know, unexpectedly, or in this particular case, I'll just do an expected one here. So system.exit, right? And I'm just going to comment this out. All right, let's go ahead and save this. Come back up, let's clear our screen, recompile. Oh, I need like a number 1 in there. Should have had a 1 in there. Let's go to save. All right, let's try to recompile that again. All right, there we go. Let's clear our screen. And let's run it. Okay, so you see calling the system.exit statement, right? And that's the only way you're never going to get this finally to actually print out, is if the program actually like terminates there. So I'm going to go ahead and put the return back in there. So that was just an example of that. This would be highly unusual for something like this to actually occur. Kind of simulating like some sort of crash, right? You know, who knows, hardware failure or something like that, right in the middle of the program there. But that's basically what I wanted to show you on that. So let's put this back here to our screen, Java C. Let's go ahead and compile this, put it back to the way it was before, right? And then finally even runs after a return statement. Okay. So the last thing that I said is that you can't have any arbitrary code in between any of these. Like you cannot put like system.out print, or how about something like this? Let's just say right, if we try to compile this, we're going to get an error here. Let's clear our screen. See, we get an error finally without try, right? So this is, oh, this try finally is just kind of sitting out there in the middle of that. Let's stick something in between the try and the catch here too. So see, we get try without catch, finally, or resource declaration, right? Right there. So yeah, you can't stick stuff in between your blocks. All your blocks basically have to be sequential here. Try, catch, finally, nothing in between there. Or you can have like a try catch with nothing in there, or try finally with nothing in there. Okay, so that pretty much covers most of the rules that I was talking about here. So no independent statements can exist between code blocks of a try, catch, finally statement. At a minimum, a try block must have either a catch block or a finally block. A finally block will execute even if there is a return statement in the try or catch block. A finally block will execute if there are exceptions or no exceptions, basically all the time. The only way a finally block will ever fail to execute is if program termination occurs, which would be extremely rare, but I simulated that there. Okay, so one of the things I said is that one of the most common uses for finally is to close file handles. It may have been opened in the try statement there. Very, very common. As a matter of fact, it's so common they've got something called try with resources that I'll go into in a couple of tutorials here. So I am going to invoke this method right here, new file intro.makefile. And the reason why I stuck this right here is if I were to say, for example, stick it down at the very bottom down here, we're going to get unreachable code because of this return right here. This return will never let this actually execute. Now, you know, the finally is different on that. After the return, a finally code block can totally execute, but a normal statement execution cannot. So anything inside of the finally block can, this cannot right here. Okay, I could stick it, I suppose, inside of, you know, the very end of that. Oh, you know, why no? Why don't I? Good idea. Okay, so even though we've got a return, we can still make like a new file there. You know, I want to show you guys this first anyway. Here, let's go ahead and just do this. All right, so if I put that there, we're going to get a compiler error because it's going to tell us we've basically got unreachable statement, right? So that's why originally I had it dropped up above this. So just go ahead and execute right there. I think I'll just leave it there. Okay, let's go ahead and save this. Let's compile it, and let me show you a couple things before we actually run it here. So this class is called file intro, and I've got a simple method here called makefile, right? Void return type, no parameters. And I haven't gone over a lot of this stuff yet, so don't worry about that. But I think you'll be able to follow along right here with me there. So Java has this FileWriter class, right? And the FileWriter class, I'll come over here, bring it up here, right? And it's basically a class for writing character files. And this is just going to be, ultimately the whole purpose of this here is to just write a file on the Java folder called hello.txt, right? That's the string literal we're passing in for the file that we want to create. Now you'll notice these double backslashes, right? And if you're wondering why on earth those are there, you'll definitely want to watch my escape sequence tutorial. That'll completely explain why there's, you know, a double backslashes there. So, okay, so back to FileWriter. So we're going to create a new FileWriter type object reference here, variable here called f, and we're going to set it equal to null because we always want to initialize it, right? And I'll explain why I'm doing it right here in just a moment there. And then same with BufferedRider out, right? Out is a reference variable of BufferedRider type. Now BufferedRider basically allows us to bring this over here. BufferWriter writes text to a character output stream, buffering characters to provide the efficient writing of single characters, arrays, and strings. So you might be going, what on earth does that mean? Well, just think of it this way. FileWriter is going to create the file, and the BufferedRider is actually going to do the writing to it, right? It's going to actually write stuff into there. So it's not too complicated there. But when we initialize these things, right? So basically we're just creating objects. This is completely safe code. These just can't fail out. If neither one of these classes existed, we had a typo there, then it wouldn't compile. That would not produce a runtime error. It just wouldn't compile, right? So these are completely safe. So we don't need to enclose them in a file, in a try block right here. So, but now when we start either invoking constructors or invoking method calls, then we need to refer to the documentation and see what will happen there, right? So for the f reference variable, I'm going to set that equal to a reference to a new instance of a FileWriter object, and I'm going to invoke the constructor that takes a single string argument. So let's come back over here to the Java 8 API and see, here's FileWriter, here it is, FileWriter, and then string file name. Okay, so when we come down here and we click on this, right, we've got this right here, and you see it throws IOException. So it throws IOException if the name file exists but is a directory rather than a regular file, does not exist, cannot be created, cannot be opened for any other reasons. You know, there could be security things, who knows. But we need a trap for an IOException. All right, that is, so let's come back over here, and so you can see I've got a catch for IOException E, and if that were to occur, I'm going to display this to the console plus E, and then I'm going to invoke the getMessage method that IOException inherited from throwable. All right, so there's also some other stuff that we need to look at here in the FileWriter class. It inherits this method called close, right? And that will close the file handle there. So what I've got here is in the finally statement. So if we can't create this file for some reason, the catch will run, and then both of these will run. So now this is out.close. And the reason why I'm calling out.close first is because that's the BufferWriter out, and I'm actually creating the BufferWriter out second, and it depends on a valid instance of FileWriter in order to actually do what it does, which I'll explain in just a second. So that's why I want to close its handle first, right? And you'll see in a second it actually throws IOException as well. All of these methods and constructors and everything in this little thing here all throw IOException, so it makes it nice and convenient on what we're going to catch here. All right, so let's come back over here. So the new FileWriter with string file name is going to construct a FileWriter object with the given file name. If it can't for some reason, it'll throw an IOException, come down to here, and then these two statements, these two try statements will try to close out any open handles. So F is a reference variable to a new FileWriter type of this particular file right here. And we are going to then create, we're going to assign a new instance. See, BufferedRider out is the reference variable there. So out, we're going to create a new instance of a BufferedRider object, right? And we're going to invoke the BufferedRider object that basically takes a FileWriter parameter. So let's come out here to the BufferedRider class. And don't worry about it. A lot of this is just kind of like way beyond where I've gone there, but I just want to show you. I think by the end of this, you'll see what the purpose of the finally is there. So BufferWriter writes text to a character output stream. So basically, in the constructor there, right, we're passing it actually writer.out, even though it's a FileWriter. FileWriter is actually up here. You can see it's derived from writer up here. It's a direct subclass of output stream writer, which is a subclass of writer, right? And you don't need to know all this yet, but just if you've been watching my exception tutorials, you kind of like, oh, okay, look, you can look up the hierarchy here on the Java 8 API there. All right, let's go ahead and pop right back here to FileWriter here. So we're looking for the constructor where we're just passing in, BufferedRider. We're looking in the constructor, we're just passing it the writer there, which is this one right here, right? And you can see this one doesn't create any sort of exception at all, right? So when we come over here, this particular statement isn't going to create any sort of exception because it doesn't throw anything according to the documentation there, right? The next line, right? Because now once we've got a reference variable to a BufferedRider object, I'm going to invoke the write method. If we come back over here to BufferedRider and take a look at the write, right, which is basically this string one right here there, you can see this one throws IOException. So this, I'm not passing the other parameters, so it writes the whole entire string there. But if an IO error occurred, an IO error could be anything like somebody pulls out the thumb drive if you're writing to a thumb drive, or if you're writing to a network location and the network hub goes down, or you're uploading a file to YouTube or something like that and your internet connection goes down. You know, all those things are examples of IO exceptions there, right? So this can throw an IO exception, this can throw an IO exception, so I only need one catch IO exception here. I don't need any other catch blocks in here because I'm not catching any other files there, right? So, and of course this logically works great, because if it's this one that throws the error, the IO exception, I'll just say unable to create the file, e.get message, right? These two lines won't even execute, right? Now then the finally will execute and it'll try out.close, right? Now because out might not even be anything yet, out might be null, right? This or null or something else or other there, but it says, if we come back here to the close documentation for the buffered, let's come back up here, closes the stream. This closes the stream, flushing it first. Once the stream has been closed, further right, blah, 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 blah. Right? So this basically is like what's called a file handle or a stream handle or whatever. But you can see it throws IO exception. So if there's any sort of error on closing this, it'll throw IO exception, and you see I'm catching it right here, right? And I'm doing nothing with it. I'm letting the program go on, and I'm doing that on purpose because, you know, if this line never executed right here, or this line executed improperly, we're just going to try to close this. And, you know, the net result of it is we were unable to create the file up in this catch right up here, right? So this line is completely safe. It won't hurt anything. This line is completely safe, and it won't hurt anything as well, right? Same thing, you know, with the F here. If for example, it crashed on this line, it couldn't create that for some reason, and our F variable was like still equal to null, and it closed it, and it caught this IO exception. We're still in the same boat. You know, we were unable to create the file as the bottom line, but our program did not crash out. But you can see down here in the finally, right? The reason why I had to put these up here is so that it would be within the scope, right? So if you've been watching my tutorials, especially on like variable scope, you'd know that if I had placed these two lines right up here, well, actually, you know what I'm gonna do? Before I do that, I'm gonna actually go ahead and run this, show you the file, and then I'll go into a little bit more detail there. All right, so let's go ahead and save this. Let's clear our screen, Java C. And let's run this guy now that we got that method. Okay, so we got everything that we got before, where finally caught exception, divide by 0, no problem here. Second finally executed, calling the return statement, finally even runs after return statement. So if we go cd ... which will make us go down to the Java folder, right? And I type in dir for a directory, you can see here's our hello.txt, right? We can either use the Java type command, type hello.txt to see, you can see what's inside of it, hello FileMaker, or if you prefer Notepad, hello.txt, right? That'll bring it up there, right? So we created our file. Everything went through just fine. No problem there. If I had done something, say, you know what I'm gonna do? I'm just gonna, I'm gonna comment these two out here. Let's say, for example, I had declared them inside of there like that, right? This is all fine and good, but the problem is when we go to try to access out and F, right? Those particular reference variables are unique only to this code block. They're only within the scope of that code block. So what we're going to get is we're going to get an error there when we go to compile this. So let's clear our screen. Okay, so error cannot find symbol, right? It can't find out. Error cannot find symbol. It cannot find F. All right, so that's basically why I did those. So by putting them out here, right, that is outside of the code block there, right? And these are all very common things to understand when you're doing exception handling. You know what's safe and what's not. If you're just going to create a simple object and a reference variable and set it equal to null, this is a 100% safe statement. You know, Same with this. It doesn't need to be enclosed in any sort of try or catches at all, right? And we can use those. That then makes this visible to everything underneath, right? Any code blocks that are inside of makes them basically local to the makefile method, right? So everything inside of the makefile method can access or do whatever they need to with these two reference variables. Okay, let's go ahead and just save this, recompile it. Put it back to the way it was. Run it. Okay, so that looks good there. There's our hello.txt. And so that is that. Now, a lot of this stuff, don't worry about the FileWriter and the BufferedRider, you know, and making this sort of stuff there. The whole purpose of this was just demonstrate the finally, right? That it runs every time. But up here, I wasn't really happy in the main method with, you know, okay, finally it runs that, finally it runs that, you know, finally it runs, okay, I get it, right? It runs every time, but what's the purpose of it? What would I ever use it for? So that's kind of why I walked you through this down here, is the finally. I mean, I would say the vast majority of the time it's actually used to close out sort of stuff there, right? Because you can imagine if we had this statement right here, let's just put this right here, right? And no finally here, right? And we caught any IO exceptions or whatnot there, right? Well then, we have no guarantees that this will execute or this will execute. Because what if it goes off on an error on the right, where we've created the new file, we've got this stream open to it, right? And then the next thing you know, this particular, when we're trying to invoke the write method from the BufferedRider class there, it fails out on some sort of IO exception. Well, then we never end up closing out of the BufferedRider stream there, and we never end up closing that file handle either, right? Now, it isn't too much of a big deal in a teeny tiny little program like this, but if this is part of a larger program where we invoke that and then we display to the, you know, the console unable to create the file and display the message, the problem is that, guess what? This particular FileWriter, with it open like that, it's not closed out. You could get some file access errors that are just super strange and super bizarre to track down. It's a little hard to explain without, you know, actually having the experience of doing that there. But just trust me on that. And a lot of this, of course, relies on, you know, okay, just thinking this stuff through and put an amazing amount of thought into everything that you do versus, like, let's say going out to like Stack Overflow and, you know, cutting and pasting and slapping some stuff in. You know, not that there's anything wrong with the cut, paste, modify, you know, mentality on that sort of stuff. It works great. It works great for just about everything. But if you don't actually realize what's going on, then when your program bugs out, it can be an incredibly frustrating experience trying to figure out what on earth is going on, you know. So it's definitely, in my opinion, worth taking the time to learn stuff, you know, thoroughly, properly, and have a true understanding of what everything does. So I'm going to go ahead and close out of this, get rid of that, and leave you with just a quick final thought there. So the one thing to take away from the finally block is that it's a code block that always runs irregardless of whether any exceptions occur in the try block or whether any exceptions don't occur in the try block. So anyway, that concludes this tutorial. Thanks for watching.